Now, the first of our theorems that you may find useful for solving some of these problems is the following. Let's take three different integers. A is not going to be 0 because that's going to be the one that's going to divide. The first part of the theorem says if A divides B and A divides C, then A divides B plus C. Now, I'm not going to go through a rigorous proof of this. I'm just going to show you an example. Okay? So let's look at this example right here. We have that 2 divides 4, clearly. 2 divides 4 because I can write 4 as 2 times another integer, 2 times 2 specifically. And also 2 divides 8 because 2 divides 8 because I can write 8 as 2 times 4. Well, putting all that together, we know that 2 is going to have to divide 4 plus 8. Okay, so that means that 2 is going to divide 12. Whoops, let me rewrite that. We know that 2 is going to divide 12 because 12 is equal to 2 times 6. Okay. Now, I want you to notice something right here, that this integer we have, this 6, that lets us show that 2 divides 12, that comes from the 2 and the 4 from the previous two examples. So whenever whenever you have an integer dividing two different integers, in this case 2 divides 4 and 2 divides 8, then 2 is going to divide their sum. So 2 is going to divide 12. Next part of the theorem says if A divides B, then A divides B times C for any other integer you want. So look at this example right here, 3 divides 6. We know that 3 divides 6 because 6 can be written as 3 times 2. And so the claim in the theorem is that 3 is going to divide anything multiplied by 6. So for example, 3 is going to divide 18 because 18 is equal to 3 times 6. So that's always going to happen. You're always going to have something like that happen. Whenever an integer divides another integer, then the first one will divide any multiple of the second one. And then the last part of the theorem says if A divides B and B divides C, then A divides C. So let's look at this example over here on the far right. First of all, we have that 2 divides 4. So that means 4 can be written as 2 times 2. Then we have that 4 divides 16. 16 can be written as 4 times 4. And the claim of the theorem is it's like a transitive property. 2 divides 4, 4 divides 16, so that means 2 has to divide 16. And it does. This is just really straightforward. 2 divides 16 because 16 can be written as 2 times 8. Now, where did the 8 come from? This is an 8, and that comes from this integer and this integer, which illustrates the divisions of the two previous ones. So that's how you can apply this theorem in different situations.